Hi students, good morning students. Observe the question number 3 from the structure of atom. PYQ question. The number of incorrect statements about the black body radiation. You know that black body radiation, from that which statement is the incorrect statement? What is the first statement? Emit or absorb energy in the form of electromagnetic radiation. Frequency distribution of the emitted radiation depends on temperature. Next, third statement is at a given temperature, intensity versus frequency curve passes through a maximum value. Next, D, the maximum of the intensity versus frequency curve is at high frequency at high temperature compared to that at lower temperature activation energy. So once look at on brief discussion on black body radiation, students, then we are identifying which option is the correct one and incorrect options. Observed here students, small explanation on the black body radiation concept. You know that already in the structure of atom, light spectrum concept is there. In the spectrum concept, light has two types, wave nature and particle nature. Wave nature is explained by diffraction, Vibgor interference, and particle nature is explained by photoelectric effect and black body radiation. The black body radiation concept is explained by iron rod heating process simply. Okay. So here take the iron rod. For suppose in the welding shops, iron rod is present. Before heating, that iron rod color is black. Once on heating at initial temperature, once temperature is rising, the temperature is T1. The color is changes to dull red. Again temperature increases, that is red color. Temperature is changes, that means temperature is increasing. So temperature increasing T1 to T5. What are the colors are observing here in the welding shops on iron rod heating? Dull red, red, yellow, white, blue. Before melting, the colors of the rod is blue color. So blue color is appears at high temperature region. So blue color is appears at high temperature region, means temperature is more here. Energy more, that means frequency is more. Blue color frequency is more. Here the red color, dull red or red, temperature is less. Temperature is less means energy is less, that means frequency less. Wavelength is more here. Okay, here the wavelength is less in this color region. So this is the black body radiation color variation changes. This color changes we are observing on the graph observed here. This is the energy versus wavelength. Initially color of the rod is red color. Red color wavelength, here the red color wavelength is more. Wavelength is nothing but the distance between the two crusts. You know that already. So observed here, this is the curve of the red color. This is the curve of the yellow color. This is the color of the blue color. Here the blue color intensity increases. Intensity increases means frequency increases. The peak of the curve observed here shifted to shorter wavelength. Here the wavelength is less. Wavelength is less, na? Here the wavelength is more. Red color wavelength is more. Temperature increases, wavelength shifted to shorter wavelength. Temperature is less, wavelength moved to higher wavelength. That is important point for examination point of view. So blue color appears at shorter wavelength. Red color is appears at higher wavelength. Blue color peak move to shorter wavelength. This is the shorter wavelength. Here this region is the shorter wavelength. Red color moves to higher wavelength. That is the point that is important, students. By using that, observe the question from here. By using this, observe the points, which statements are number of incorrect statements they are asking. Emit and absorb energy in the form of electromagnetic radiation. So here black body iron rod heating, the energy emitted in the form of electromagnetic radiation, different colors are appears. So first statement is correct statement. Next, frequency distribution of the emitted radiation depends on temperature. Frequency distribution of the emitted radiation depends on temperature or not? Yes, temperature. So second statement also correct statement. Next, observe the third statement. At a given temperature, intensity versus frequency curve passes through a maximum value. At a given temperature, intensity versus frequency. This is T1 temperature, this is T5 temperature. Temperature is high, temperature is less. So temperature is T3 is high, T1 is less. So T3 temperature increases, wavelength is decreases, frequency increases, higher frequency na, so maximum value. That statement also correct statement. Next, the maximum of the intensity versus frequency curve is at a higher frequency at higher temperature compared to that lower temperature activation energy. Correct. At higher temperature, energy is more, frequency is more. So option D also correct statement, students. Black body radiation, graph important, as well as this process of conversion, temperature change, frequency change, wavelength change, relations are important. Next, observe students here, question number 4, 2023 January session question, mains question. This is also related with black body radiation. This question based only. From the following black body, 4 different temperatures are given. The correct statements they're asking. Correct statements. What is that one? T4, T3, T2, T1. T4 is more compared to T1. T4 is more compared to T1. T4 is related with red color. T1 is related to blue color or white color. That is mentioned here. T4 is more. That is correct na? No. So here the blue color temperature is more compared to red color temperature. So this one is the incorrect. Next, the black body consists of particles forming simple harmonic motion. No. Next, the peak of the spectrum shifted to shorter wavelength as temperature increases. So temperature increases, the peak shifted to shorter wavelength. Na? This is correct. Na? This is shorter wavelength. This is red color, higher wavelength. So C also correct statement. Next, C is the correct. What about the D? D is actually the relation is T1 by nu1 is equal to T2 by nu2 is equal to T3 by nu3. That is the constant value actually. So this is the correct. Once if you are checking the values, the value is the constant value. So D is the incorrect. The given spectrum could be explained using quantization of energy. What about the energy here? Packets of energy. Na? The packets of energy means energy is not existing continuously. Means red color appears at one temperature, yellow color appears at one temperature. This wave not merging to each other. They are existing at different temperatures. So the red color is appears at particular temperature, then yellow color is appears another temperature. Both are not merging to each other. One color is appears, then another color is disappears. So quantization of energy means packets of energy. So it is the particle nature of the light. Particle nature of the light is nothing but quantization of energy. So options C and E are correct statements. Observe the next question, students. Here photoelectric effect based question, work function based. Here the metals, different metals is given, different metals work function values are given. The number of metals which will show photoelectric effect when light of wavelength 400 nanometers falls on it. It is light of wavelength means incident light. You know that already photoelectric effect on metal atom on the surface of the metal. This is the metal. On the surface of the metal, electrons are present. Certain frequency of light strikes on the metal, ejection of electrons takes place. That concept is called a photoelectric effect. When the electron ejection takes place, so certain energy of the light, that means frequency, certain frequency of light strikes on the metal surface, ejection of electron takes place. Here between nucleus and this valence electron interactions are present. Na? That interactions are threshold interaction, that is threshold frequency. So compared to threshold frequency, incident light frequency is more, photoelectric effect is possible. That is in terms of frequency. What about in terms of wavelength? Nu is equal to C by lambda, the relation you know that. So here the wave frequency is more, threshold frequency is less, photoelectric effect is possible. Now in terms of wavelength, reverse. This is incident light wavelength, this is threshold wavelength. Threshold wavelength is more compared to incident light wavelength, photoelectric effect is possible. Remember, this is in terms of wavelength. In terms of frequency, incident light frequency is more compared to threshold frequency, photoelectric effect is possible. Reverse. So by using this point, Here the incident light wavelength is given. This wavelength convert into in terms of frequency, that frequency value observed which metals, how many metals, less value compared to incident frequency. Okay, now E is equal to h nu, the formula. H nu is nothing but C by lambda. So h is equal to Planck constant value, how much? 6.626 into 10 power minus 34 joule seconds. And C, velocity of the light, 3 into 10 power 8 meter per seconds. Wavelength value, how much is given? 400 nanometers is given. 1 nanometer is equal to how many meters? 10 power minus 9 meters. Okay, na? What is cancellation here? Meters get cancelled. Seconds get cancelled. What is remaining here? So E is equal to 6.626 into 3 by 400. I am writing as a 4 into 10 power 2. 10 power 2, 10 power minus 10, 10 power minus 7. So move to the up. 10 power 7, 10 power 8, 10 power minus 34. So 6.626 into 3 by 4 into 10 power 15 10 power minus 34. How much is remaining? 10 power minus 19. Units is what here? Joules. Okay, now. So simplifying this value, after simplify this value, how much you are getting? 6.626 into 3, almost 19.8 students, by 4 into 10 power minus 19 joules. So this value almost 20 by 4, almost nearer to 5. 4.95 into 10 power minus 19 joules. So here 1 joule is equal to how many electron volts? Relation is there, 1 joule and electron volts. 1 electron volt is equal to 1.602 into 10 power minus 19 joules. That is the relation between electron volts and joules. So this joule value substitute here. So 1 electron volt is equal to 4.95 into 10 power minus 19, 10 power minus 19 by 1 joule is equal to how many electron volt? 1.602 into 10 power minus 19 electron volts. 1 joule value, 1 by 10 power minus 19 electron volts. So after simplifying this value, almost you are getting 3.09 students, 3.09. So observe here, this value is more than to lithium and more than to sodium, more than to potassium. So how many metals involved in the photoelectric effect? 3 metals. Because of this value you are getting more than these 3 metals. This is in terms of frequency. Okay, now students.